I'm going to present a technique for cutting thin wooden strips used in inlay and splines. In my applications, thin means a thickness in the range of a 1/16 of an inch to an 1/8 of an inch. However, there is no inherent restriction of the method to this thickness range. Furniture pieces inspired by the Federal period often contain nominal 1/16 inch wide string inlay that can be made with my approach. Mitered corners are often reinforced with nominal 1/8 inch thick splines, which can also be made with my technique. Many other thin strip examples exist in the woodworking literature. There are commercial jigs that cut thin strips. I own one that cost me less than $30, but it does not fit tightly in my table saw miter slot, nor does it have control down to a few thousandths of an inch. There are also YouTube videos on how to construct a shop-built jig. By contrast, all the hardware necessary to implement this method already existed in my shop. No special purpose jig was constructed for this technique. I hope you find this video informative. Here are two examples that I've built that required thin strips, and I used the techniques described here to produce them. On the left, the lap desk was inspired by the Thomas Jefferson design that resides in the Smithsonian. The slot for the beading on the drawer front was cut on the router table with a nominal 1/16 inch end mill. On the right, the Rob Kosman style hidden hinge box used splines to reinforce the mitered corners. The slot for the splines was created by a nominal 1/8 inch kerf flat bottom saw blade. In both cases, the tool for the grooves and slot determined the required thickness of the thin strip. In what follows, a saw kerf from a nominal 1/8 inch will be used as an example. To start the process, make a rip cut and a sample piece of wood of the same species that will be accepting the thin strip. If this species is not available, select a similar hardness wood. Find the combination of gauge block and feeler gauges that will barely slide freely in the saw kerf and measure their combined thickness with a caliper. The manufacturer's printed thickness may not be sufficiently accurate for this approach. This thickness is a good estimate of the saw kerf. Some judgment will be required to determine if the thickness of the thin strip should be reduced to account for the glue joint. A good starting point will be to reduce the thickness by slightly over 2/1000th of an inch. The stock from which the thin strips are cut should have a flat bottom. This will produce a straight edge on the bottom edge of the thin strip. It is also important to have parallel opposing faces for the edge against the rip fence and its mate. The dimensions of the stock can be adjusted to fit project requirements and the availability of your wood. The mag switch featherboard ensures that the stock stays against the rip fence. In addition to moving the stock through the saw blade, the push block also keeps the stock flat on the saw tabletop. At the end of this step, clamp the stock block in place. This establishes a starting reference point for subsequent rip fence moves. In some cases, it may be desirable to have the top and bottom faces of the ripstock parallel. This allows one thin strip to produce two pieces of string inlay. Each rip operation needs a reference rip position. This is established from the previous rip, which leaves the uncut thin strip stock in intimate contact with the saw blade. At this stage, move the stop block adjacent to the rip fence support arm as shown in the photo and clamp in place. The support arm of the rip fence is identified and it is rigidly attached to the rip fence. It provides a repeatable flat surface to register the stop block. Experience showed that bumping the support arm against the stop block with only magnetic switches engaged could cause a slight stop block motion. Consequently, it is imperative that the F-clamp be applied. The blue you see next to the rip scale is painter's tape, and it has nothing to do with this project. At this point, we're almost ready to make the rip cut. First, the rip fence must be moved over an amount that is roughly twice the saw curve. Remember, you're going to lose one saw curve from the material to the left of the right edge of the saw blade. For the example problem given here, twice the saw curve of 0.128 inches is 0.256 inches. Select a gauge block plus feeler gauge such that their combined thickness is 0.256 inches. This was accomplished by a nominal quarter-inch gauge block plus a 7/1000 inch feeler gauge. Remember, measure the combined thickness with a caliper. Unlock the fence and move it away from the stop block. Insert the gauge block feeler gauge combination adjacent to the stop block and gently move the fence into position. With my table saw, repeated cycles of lock and unlock of the rip fence gives a slight movement to the right. Once good contact among the support arm, gauge block feeler gauge combination, and stop block is established, lock the rip fence in place. This approach gives very precise and repeatable fence movement. You're now ready to make the rip cut. With a single push block and no feather board, there's a tendency for the saw blade to propel the offcut towards the saw operator. The addition of the feather board impedes the offcut path and may cause the offcut to strike the saw blade and cause damage. Consequently, it is recommended that a second push block be used. The second push block should be engaged just before the rip cut is completed. For safety's sake, try to keep your left hand to the left side of the saw blade. This technique has safely worked for me. The first thin strip should be tested in the groove that was created. If you're not satisfied with the fit, then adjust the combined gauge block feeler gauge thickness accordingly and repeat. Once the fit is acceptable, go through the process of moving the stop block adjacent to the support arm and clamp it in place. Unclamp the rip fence, insert the gauge block feeler gauge combination adjacent to the stop block, move rip fence back in place, and clamp it. This process is repeated for as many thin strips as necessary. Always make a few extras. Once all setup adjustments are made, the actual ripping process takes very little time. This photo shows the results from 3 rips. All 3 results fit the saw curve nicely, indicating that repeatability is good. The numbers written on each strip are the measured thickness. Again, there's repeatability. I hope these results will convince you to try this method the next time you need thin strips for inlay, joint reinforcement, or for some other project. In summary, a technique has been presented for making thin strips to fit an existing slot or groove. No jig construction was required, and I only used tools that I already had in my shop. The use of gauge block feeler gauges for moving the rip fence between successive rips is what makes the process very reliable and repeatable. Skeptics will likely be critical of having to move the rip fence for each thin strip rip. I suggest they try the method before passing judgment. The overall time required to move the fence the desired amount is small in comparison to the total project time.